and today the third day of our World Skills Agile camp in Ground Operating Skill. So today we will tell you more about Gazebo simulation environment, and we will go deeper in our skill. So first of all, I would like to remind you about the schedule. Today, day for lesson and practice, and tomorrow will be our final day. And this final day, you will perform in the final task, which we shared with you in the end of day. So, and today will be more practice, more advanced level in Gazebo environment. Feel free to ask us about it, and don't forget to perform your homework because it's very important. It helps you to train your skill, and also it helps us to find your not strong sides, to find your mirror, to find your errors or another difficult, and we can solve it together if you will perform the homework, of course. So also yesterday we have more technical questions, and today it will continue. So feel free to ask us about it, or in our common group, or personally to Artem Batalov, Yulia, and Timofey. We will help you, of course. So, okay, I think we can start our classes, and let's welcome Yulia and Timofey. Guys, connected.
Hi.
Great. Okay, I wish you good luck and see you in our evening briefing after lesson. Okay, Yulia, Timofey, welcome.
Okay, good morning. So now I think we should start from our homework. I got some results from some peoples. It is Jacques and Bruno from Brazil. They sent me full homework and flip, of course. So I think some people send their homework to Svetlana and Timofey. We will make your schedule with your marks some later. And now I would like ask somebody of you explain how you make a flip if you understand how it works. Maybe Jacques or maybe Bruno or Mohammed who understand how it works.
And Stotam, of course. Guys, don't worry. You can share your experience and share it, your results. And please, I think it will be really interesting if you describe or explain how it works for other participants, and how you performed your task. Okay, it can be Stotam, Bruno, or Jacques.
I saw your homework. It works good. So I will send it to general chat now, and it will be great if you tell everybody how it works. Totem made double flip.
Hello.
Hello.
Yeah, I'm Stotam. Can I share the screen?
Yes, of course.
Okay.
Be a star, be a hero.
Is it visible?
Mm, just one. Yes, yes, great. Perfect.
Okay. This is my code for the single flip. This is a code define the function for flip, and it has 20 and thirst 0.9 per and
Okay, but it's seems with some delay.
yeah,
Maybe
that was for the single flip.
yeah, maybe you explain how it works and show us your video. I think it will be required. It takes minimum characteristics and it will be without delay. Maybe I'm not sure, of course, but maybe it takes minimum resources if we compare it with simulation.
This is for the double flip. Okay, that was all.
Yeah, okay. We have seen a video on Telegram. Okay, thank you, Stota. Yeah, who would like to explain the code, guys? Oh, it was difficult, yeah, difficult task. Okay, Yulia, Timofey, could you comment it?
Yes, wait a second. Can you display the code?
Just a moment. Mustafa want to comment it. Maybe. Okay, guys.
Yeah, go ahead, Mustafa. I would like to hear your comment.
Okay. So I think I'll share my screen. Hello, everyone.
Hello, hello.
Can you see my screen?
Yeah, yeah.
Okay, great. So I'll just be explaining the flip part, because I think everyone gets the navigation part from Timofey and Yulia explaining them yesterday. Thank you, by the way, for that. So basically the flip part, which is in my code, this small part, it's a function. There was two ways for the drone to flip, which is a roll flip or a pitch flip. I used a roll flip. A roll is basically a flip around a specific axis. So what the function does, it does a couple of things. First thing, it saves the initial position, the initial telemetry of the drone, for it to be able to use it after the flip at some point. I'll be coming back to this in the end. First, it gives the drone a thrust or an initial thrust to be able to do this the flip without falling to the ground. Then you have to increase the rate for a specific uh, uh, orientation, whether it's the roll or the pitch. So using the roll flip, I had to increase the roll rate, and experimenting with different thrusts. 4.4 worked for me. I think you can experiment with different values for thrust to see if it works or not. The best way to do this is using the dynamics of the drone, but this is another way to do it, which is trial and error. So basically, this is the part that does the flip. It starts to increase after increasing the rate for the roll and the thrust. It starts to the drone starts to flip. This functions starts monitoring the angle for the drone. The more it increases, it compares the actual angle for the drone with a value, preset value. That value, I had to experiment with that value as well, which is a different angle. In my case, it was more than a quarter of a circle, which is around, I don't know, 100 something degrees. So it keeps comparing the angle. When it reaches that angle, let's say a quarter of a circle, it will stop flipping. Then it will use the initial position that we talked about earlier. It will use that initial position to return to. So when you reach a specific angle, it will come to a stop concerning the flip and will start to stabilize. There will be two ways to do it. Is there a way to annotate in this thing? Okay. Let's say the drone reached 180 degrees. I don't have a way to annotate on my screen, unfortunately, but I will try to explain it. If you reach halfway of the flip, there's two ways to stabilize, whether it's returning backwards or continuing the flip to stabilize, and that's what the drone does. Continuing the flip is the best way because the drone already has inertia in that direction, so it continues the flip and stabilizes in that direction. So that's basically how my flip works, and that was the example provided in the code snippets, and that's what I used. I think that's about it. Are there any questions? Can anyone hear me?
Thank you for your comments. And yes, guys, if you have any questions, Mustafa will answer it.
Okay, thank you very much.
So, okay. If nobody have questions, thank you so much, Mustafa. It's really cool you understand how it works and explain it to everyone. Thank you. So now Timothy will tell you about one important thing and one important service in this code. It is set position, and we can use in this code only set position. And I think Timothy now tell you why.
Yes, sure. I will tell you why. Can you share us share your screen with us?
Yes, one moment.
Maybe with code for the flip.
Oh, I think Mustafa can share his screen with his code. It was
Yes.
This was good, really. Mustafa, can you share your screen again, please?
I already did. See my screen? Can you see my screen?
Yes, yes.
Okay.
Yeah. So here I can see your screen, and for you guys who didn't use set position before, you can see the line 51. It says set position x equals start x, y equals start y, and z equals start z. Then yeah equals start yeah, which is it looks pretty similar to navigate, as you could notice. But this set position is missing one important thing. Is it is speed. So in set position we do not set speed. It just doesn't have such an argument. Why would we even use that? Well, for example, if we want to travel to a particular point at the speed that is convenient for the drone. For example, if the point is pretty near to your drone, like 10 centimeters from the drone, from where the drone is now, you don't want to calculate the timings, the speed for travel. You just want to tell the drone go to this point, and the drone will move to this position pretty quickly. But if the distance between the drone and the point where it is moving is too high, like it's too many centimeters, maybe 1 meter or 2 meters, then the drone will go too fast, and it's not safe to use set position in this case. So you need to make sure that every step when you use set position, that step is quite small, so you don't have to travel vast distances. And why and how do we use it in our code? It is very useful when, for example, you have a function that calculates the drone's position, the desired drone position, several times a second, like maybe 10 times or even more, 20 times per second. So, and you can control the speed of the drone, not by passing the speed parameters to set position, but by changing the position over time. So you have a more general control over speed. You just tell the drone like 10 times a second where to go, and the drone will follow your command. You can find a code that uses set position just that way in the code snippets article, and I recommend you checking out the code for circular movement. Mustafa, can you open the documentation for us to show this article, and I will show you where to find this code, and later on, maybe today after this lesson, you could check it out yourself and try to make a circular movement with your drone. So there has to be a code. Yeah, just Control F and write circle. Yeah, circle a path. So here you can see this code snippet contains a while loop. Of course, you can wrap this whole piece of code into function, which I recommend you do. And this function will have while loop, so while not respy is shut down. You remember I told you before. And first, it calculates some variables for getting current angle on this circle, then calculates x and y in particular moment of time, and then you have set position where you provide x equals x and y equals y, and z equals start z, which means that you do not change z. So x is calculated by the sine function over from time, and y is actually cosine function. And how do you alter the speed? Well, you alter the speed by the angle variable, which is actually time. So it increases as time increases, and you can slow down or speed up the change of position by multiplying it by the speed constant, which is given in the beginning of the code. So basically, this code is just for your self-learning, and after we will not check this out today, but you can check out yourselves and try to make a function so you can call it multiple times in your code. All right, this is basically what set position is. Of course, you can provide different frame ID to set position, and the whole list of arguments is available in the article simple of board. You can find it on to the left side on this site. Can you find the article simple of board? Yeah, and find set position here. So the list of arguments that are available here is XYZ, which is coordinates, then yaw, which is calculated in radians. So you provide radians to this argument, like pi radians or pi over 2, and so on. Yaw rate, which is the angular speed for the change of yaw. Auto arm, of course, you can even take off with set position, which I do not recommend. And the frame ID. So you know how to use it already. You can use any frame ID available for navigate. And here are some examples for set position. I don't think they are very useful because, for example, if you set position x0, y0, z3 from body, it means that the drone will fly as crazy, 3 meters high, and it may hit something while taking off. So I do not recommend you copying and pasting these code snippets from here. Just use set position and in places where it is necessary to. We needed to explain you this service because you used it in your homework, and you can experiment with some functions like sinus, sine, cosine, and some other functions that you want to calculate, for example, of time, and set the coordinates to the drone by set position. So this is it about set position. Julia, I think you can continue with the next topic. Thank you for this screen share.
Thank you, Timofey, so much. And it was really important to understand because it is can be part of our final task. Svetlana, can you share our final task, please?
Yes, sure.
Oh, thank you so much. Yes, it's okay. Yesterday I said you will have one competition day, and what about task for this competition day? It's first. It will tomorrow in first part of our in first part of our lesson. And you will have only 1 hour for programming special task. And okay, what about it? We will study today how to create some objects in Gazebo simulator and how use it. So you should understand it very good because tomorrow it will the main part of your task and competition. The first one, you should create 3 objects. It is takeoff zone and landing cube and ladder with 3 levels. After it, you should write a program for drone for autonomous flight. And drone need to take off from takeoff zone and fly through all levels of ladder, and after it land to the cube. But if you was very good students and many of you was, you can write flip program for flip, or you can take it from your homework, and after ladder you can make flip and then land to landing box. It will give you more points. So that's what about your task for tomorrow competitions, and be a good student for today, and you will complete it tomorrow very good, I think. So if you have any question, you can ask me now. So nobody have questions. about final task? Okay, very good. Then let's start our today's lessons. Today lesson. I will share my screen. Can you see it?
Yeah, we see it. Great.
Okay. So yesterday we used some services and topics but what is mean services and topics? It is a part of a robotic operation system what we use in our drones to control all parts of our drone. Services allow us to make one actions or ask drone to do something. For example, we can ask drone fly to point with service. We can ask drone give the telemetry with service, and it is like services allow us to make some action one time and maybe get response, or if we don't need it, just make some actions. Topics, it is like maybe chats where in other programs or part of drones can send messages.
Telegram channel.
Like a Telegram channel, yes. So it can be some information from camera, and program what works with camera just send some message in topics all time, and it doesn't matter for camera read it somebody or not. I think I will show you how it works, and you can see it in your Gazebo too. We need to open our terminal and simulator. The first of all, I think we can see all topics. How to make it? I can write ROS topic echo and press tab. It asks me want I show all topics or not. Yes, and I press yes, and it showed all topics. Okay, it looks very strange. Yes, I will make it. Yes. Okay, I can try it. It doesn't matter. So what about topics? We have a lot chats where some part of drones or some programs send information all times. For example, let's try to subscribe for one of topics. For example, let's subscribe to Mavros State, for example. And now we can see a lot messages what sent it to our topic or maybe our chat, and we can see information about our drones there. For example, frame and is it connected or not? What mean connected? When we use Raspberry Pi in our drone, we connect it with PixRacer or PixHawk with flight controller through USB, and if it is connected with flight controller, if Raspberry connected with flight controller, the status will true. If not, it will false, and it means drone can't fly under Aruka map in afternoons. So the next one, it is armed status. Now our drone placed on the ground, and it is disarmed. So the status is false. And another parameters. So let's try to do something with our drone, and these parameters will change it. For example, we can take off. I will just open new terminal.
Take off using this.
Okay.
You write here commander take off.
So
this is another way to take off easily.
Thank you, Timothy. Very good feature. You can use commander takeoff there. So now our drone take off, and parameters in our topic was changed. Connected true, and now, for example, armed true. Mode was changed to after takeoff, and system status was changed too. So that's what about topics. I can stop topics with Control C points. We can check another topic, for example. For example, topic with rangefinder, and in this topic we can see measurement from our rangefinder. Somebody turn on his microphone. Ari, I think it is your microphone. Okay, thank you. So, topics with rangefinder data. Now we can see how range change in real time, and our drone take off on 2.6 meters up, and we can see it in simulator. So now rangefinder placed on this drone in bottom part, and we can see measurement from rangefinder in this topic, and we can use it in our code too. We can make subscriber on this topic and use measurement from the sensor for our mission, for example. So next one, it is ROS services. ROS services, it's like some commands what we can use to control our drone or our system or some another part of program. What about services? What we have? I think you know this service and you used it, get telemetry, and you know land service, and I think you know let's set effect service, and maybe you know this service too, navigate. So that is all services what you can use to control your drone. And wait, turn off your microphone, please. Wait, please turn off your microphone. So. Sveta, can you mute new people's? Okay, thank you. So that is a list of all services in our system, and you can use any of it in your program and in Python program, or you can use it in terminal too. For example, yesterday we used ROS service get telemetry service or navigate. You just should to write a service call, and after it service name, and press tab, and system will write some parameters for this service, and you can set up some parameters for it. For example, I want to get telemetry in Aruka map. There, I just write this command, and I get only one answer for it. If in topics we can get a lot of information sometimes per second, then there we can get information only one time. And now I got coordinates and speeds and some angles and voltage. So any of these topics you can use or from terminal or from your code. I think that's all about services and topics. So now I would like to you check this material in your simulators. So please try to get some information from any topic and from any and make some action with any services in your simulator, and send photo to the chat, please. It's task for everybody, and you have 5 minutes for it, I think it will enough. So please subscribe to any topic, and please make a screenshot and send it to the chat, and after it call any service and send result to the chat too, please. So let's start. So waiting for your screen in chat. Okay, thank you, Mustafa. Thank you, Jacques.
And one more important thing about topics for you is you have a list of video topics that are available on the browser. So if you open a Mozilla Firefox here on the desktop and type the address local host 8080, and here we have multiple image topics available for us to see. For example, image raw, it is a video stream from camera. If we take off, we can see the change in picture. So yeah, this is the taking off. And the drone is flying over here. This is the image. Also, we have Aruku detect debug, which is how the drone recognizes Aruku markers. There's also optical flow debug. Optical flow is the system for determining the drone's change in position that works without markers. So you can use optical flow even without Aruku marker field. And there is Aruku map image, but you better click on the snapshot here. It is a map of markers that is available for us. And the last one is Aruku map debug, which is basically the same as Aruku markers, but it also builds the frame of reference from here, the X and Y coordinates. And for example, if we go anywhere else, you will see which number and in which marker is assigned to. So this is the marker 90, which is here. And those are image topics that are available for you when the drone is running. But I do not recommend you opening these topics from terminal. It will cause a lot of troubles for you because the information flow is so high. You will be overwhelmed with data and the terminal will break. So do not echo these topics. Okay, this is it for topics for now, and now we can continue with a new thing to learn, which is how do you change the environment, how do you add objects on the scene, how do you edit them. And let's begin. Are you ready, guys? Tell me if you are. Oh, you want the link for entering this?
А я написала в чат.
So the link is already there, and now we can continue with editing the environment. So for example, if I want to add some object on the scene, I can do a few things. The easiest way to do it is clicking some of these three objects, and you can put them like this. And as you can see, the drone did bump up because it recognized that the distance under it was changed, and it adjusted its height according to this distance. And I can land on this cube. If I write Commander land in the Gazebo terminal, the drone did land on the cube. But this is not the best way to put objects on the scene because this is standard. It can cause some troubles for you later. And we want to edit and create custom objects. Oh, as you can see, the drone is trying to move this cube, and it will eventually. But what I will do now, I will pause the simulation. So this way you can pause the simulation. And let's enter the model editor. Go to edit, model editor. And this is a better way to create models. Let's build something pretty simple. I'll take a box. And let's create a column out of this box. So I choose the tool for scale model, and I will reduce the width of this cube. I can increase the height, and now it looks like a column. Now let's copy this one. I pressed Ctrl C and Ctrl V. I can move it with my mouse. And we can add a horizontal bar as well. If I press Ctrl V again and choose the rotation tool, I hold Control to keep it horizontal, and this is our horizontal bar that we will put on top of this model. This is not a 3D editor, so Gazebo is just a simulator. It is pretty basic and not very powerful compared to something like Blender or 3D Max or something like that. If you want, you can even import models from these softwares. Okay, this looks like a gate now, but we will need to make some changes to it. Let's first let's say this model is static, that it's not affected by physics. So whenever a drone hits this model, it will not break. So the model now is static. You can also edit the properties of each component by right-clicking on them and open link inspector. And here you can find pose of the subject, where it is located, and you can even change the color. Let's change the color to make it red. So the color is changing here. Let's increase the RL value in ambient and in diffuse. It's now reddish, but not entirely red, so you can decrease all the other values for green and blue, and over here as well. And okay, it will change the color once we exit the editor. It will be a little bit brighter. And let's see what we've got. So you can save this model. I'll call it gate 1. And now we can exit model editor. And this is our model. You can select this model and move it around the scene anywhere you want. You can also insert it here. Is the gate 1 that I've just made. I also made previous versions a couple of days ago. I will not use them. So if I select gate 1 from here, as you can see, it's not located properly, so I can select it and move it up. Oh, and it is actually pretty tall. It's taller than I thought, because the bars increased its height even underground. I accidentally moved the floor, so I need to change this tool to be able to do this. And you can put as many gates on your scene as you want. And let's try to run the simulation. Yeah, it didn't break because sometimes after you enter the editor, the simulation stops performing, and you'll need to restart Gazebo. But now it didn't, so you can take off again. At least if the drone will get unstuck. Maybe I should just delete this object. All right, I deleted this object, and the drone doesn't want to do anything. I'll have to restart it. But first, before I restart, I want to save this scene, and I will show you how to do it properly. So in order to save the scene, you need to delete the drone from your scene, because it will also save this, which is what we do not want. So select the drone and press delete. Now you do not have a drone. And this is the scene with our gates. I can go ahead and file save world as, and for example, in home, I will call it my MW, which is my world dot world. Save. All right, it's saved the world. We just saved the world. Okay, let's exit the Gazebo. And what do we do to actually open it? Well, it's not going to be so easy, because the standard world is located in a folder which is home, captain.ws, src, Clover simulation, resources, worlds. And the world we are using now is called Clover Aruko. And I will have to replace this world with our world. So let's rename it. I'll copy this name and change it to something like underscore Clover Aruko. Rename. And I will put my newly created world into this folder and rename it to cloveraruko.world. All right. I think you will need to use this path. Just remember where it is located. It's home, Clover, captain.ws, src, Clover simulation, resources, worlds. And now let's go ahead and open up the Gazebo again. Okay, and now we can see that the world is saved with all the models that we've put previously. And this is how you actually put models in Gazebo. The next thing we want to do is edit model. For example, I see that this bar is not in the place. I want to change its position. I can click my model, right click, and edit model. Now I'm in the editor again. I can select this bar and move it to the right position. And now I can say File, Save, or I can even exit model editor and save and exit. Save. And now the model has changed. Let's see. The other model hasn't changed, but we can delete this model and insert one more, which is already correct. Okay. This is how you create your model. And do you follow my steps, or you just watch the stream? Can you write if you have done the same already? Oh, just watching. Okay. You will now train yourself to do it. So the next task for you is to create something like that. Let's see the task. Yes, Julia will show you.
So let's try to make it by yourself. And we have a picture of a little scene on the screen now. And let's try to create it in a simulator, in your simulators. And we will make it with you step by step, but you should repeat all action and try to create the same scene and send result to chat. And I hope you can make it. And if you have any questions, you can ask us in real time when we create this scene. And you can say just stop, I don't understand, repeat please. So let's try. So Timofey, now I will send this picture to your Telegram chat, and after it, we will open our Gazebo simulator too and start create this scene. And please make it in your simulators too.
Okay, you see my screen. And this is the scene that we just created. I will delete the object that I don't want to have, but this one will stay the same, so I will not change it. I hope you remember how to create it on your own. But for now, I will create another model called maybe pillar or something like that. Yes, so I press edit and model editor. Then I select a cube, I put it on the scene and select this tool. The fourth tool, which is scale model. And I'll scale it down a little bit. Yes, you need to do it in your simulator. As you can see, it scales underground as well as up. So when you create this model, make sure you put it up from the ground. And this is what you need to do yourselves. Write us in the chat when you're ready with this and when I can proceed to the next step.
If somebody have problems with editing, please say it and we can repeat all it.
Yes, I have some problem. I, I already insert the shapes, but somehow my simulator gazebo uh, is hang. I cannot move anything.
Well, I think if it doesn't go well, you will need to restart it. Sometimes it happens, maybe when the computer is slow, but I think it may happen on any computer, so just restart Gazebo if it hangs.
Just restart the gazebo or the virtual machine.
Only Gazebo. For those of you who want to proceed to the next step, don't forget that you need to enter Model tab and hit Static. Model tab and Static for those of you who made a pillar. If you saved it without static ticked, you need to edit this model and tick static.
Somebody finished or not?
If all of you has done what I just done, I can continue. Or if someone has problems, just tell us and we will help you with them. Well, if nobody is telling that they have problems, I think everyone has done what I just did. And let's then save this model file, save. I'll call it column and save file exit modulator. Okay, and this column is on my scene. I can move it wherever I need to. It's better to put it not on the arc marker but in between. Okay, and I can insert some other columns where we want to. I'll put them up later. Сколько их там должно быть? And let's move them up. All right, and now you can save this world file. So to save, did everyone put all their columns on the scene?
So we have some questions in chat. Mustafa, we need create two models. The first one is gate, and the second one is column. So guys, please write to the chat who finished this task. I saw Ghazali have some problem with Gazebo, unfortunately, but nobody knows write it to the chat about their success. Please write plus if you finish, or plus or minus if you have problems with it. Mustafa, okay, I see. Can you send a picture to the chat, please? Maybe somebody else already finished. Bruna, Muhammad, Marcus, how are you? Oh, great, Mustafa. So while we waiting for uh, everybody finished, you can just write a little program uh, for this obstacles, and you can fly through these obstacles if you finish. So, and Timofey said you should save this one, and he will show it now.
Yeah, just before you fly, make sure you save this world in order to not lose any changes. If you have saved the models, they will stay there even after you restart the Gazebo. But what if you want to but if you will close it right now, it will lose all the model positions. So you need to save the world without Clover. Select Clover and press delete. Then you have a clear world that you can save. And let's do it the way, a little bit other way than previous one. I will save it as the same file as we opened. So go to Katkinway, WS, SRC, Clover simulation, resources, worlds, and select Clover Aruka.world. And now press save and replace. All right. This way we will not need to move our files anymore. So just you can close the Gazebo, and after we close it, you can open it again. Okay, and you can see that the world has opened with the same models in place. For those of you who didn't follow me, I will show it again. So you have all the objects on the scene. You press Clover.
So, guys, let's continue. If you there, please write plus to the chat or say something. So let's try to write program for fly through the subjects. And the first one, what I need um, to understand the coordinates where my drone should fly. The first one, it should take off from this point, and after it, I should fly to this points and fly through gap. After it, I will fly by line through these gaps step by step, and after it, land. Let's try to write it. The first one, I copy all libraries and proxy to services from Gitbook. I think I open it with VS Code because it's more comfortable to use. So after it, I should take off. So the first point will point near the gap, it is I should fly to there, because if I will fly from start point to the gap, I can touch it, and I shouldn't break it. So I should first fly to this point. It will be near 1 meter by x axis and 0 by y axis. The first one, it is 1 meter by x and 0 by y, and I think it will be 1 meter enough by z, and 0 will arrow come up. You can use body actually, but it is not so comfortable to use, because you can give real coordinates. So it was first point. Second point will I think 1 meter by x and 2 meters by y axis. And there enough 1 meters by z coordinate. And the next point will point between these columns. I think I should make like with gaps and fly to this point before I fly through columns. It will 2 and 2 by x and by y coordinates. And the next one will 0 by x and 2 by y coordinate, and it will be there. The next one will be 3 by x and 0 by y. The next one will 3 by x and 2 by y, and the next one will 4 by x and 2 by y. I think yes. And the last one is will 0 by x and 4 and 4 by x and 0 by y. So I think that's all. I can land, and I think I can make speed more. So let's check it. Oh, I'm sorry, I have a little error. Что такое? Все сломалось? So I will restart it. I will restart it. So sometimes you can have some problems with your simulator, so the best way how to fix it, just restart it. So I have two ways how to back it to the start point. The first one is write little program and come back it to the start point. The second one, and it is easy, just restart it. So let's try again. And landing. So that's all. It is the same like you will have tomorrow task in your competition, and I hope it will easy for you. So now we can continue and discuss how to create a Ruka map, I think, because when you uh, when you preparing to any competition and what skills of course, you will make it not only in simulator, and you will make it on real drones in a real flight zone. And you should understand how to create a Ruka map and how to print it, and how set up it for the drone. And let's discuss it. I think we should to start from Aruka markers, the first. That's enough. Only one Aruka markers to keep position. And if you should just check your drone is autonomous, and if can your drone keep his position or not, it will enough only one marker. And if you want create this marker, you can use any generator. For example, maybe like this, for example. We use 4x4 markers, so we have 4 pixels on 4 pixels inside, and we can write marker ID. I like number 8 because it looks like a fish. So, and there you can write the size in millimeters. So if you want fly on the height, maybe from 1 to 3 meters, you should use markers maybe from 30 to 35 centimeters. So there I will write 330 millimeters, and it will be 33 centimeters. And there I can save it. I can save it in different formats. I can save it like SVG, or I can open it to save it in PDF like this. And I can print it on any printer, but you need to remember you can use markers only if it hasn't any blinks, because if you have a lot light in your rooms, sometimes your paper and your markers can give blinks and reflections.
They shouldn't be reflective.
Yes, and the system will not work stable. So that is the first way how to create real marker. The second way, it is generator for full field. For example, you can make it in Gitbook. I think we have it. No, we have it only in Russian version. I sent it this link yesterday, so you can create full field there. It doesn't work anymore. Looks like that. So I think it is wrong way. It doesn't work anymore. But we have another way. because you set up your Aruka map in Clover image, and you can see it in these topics in this topics list. And if you open Aruka map image, you can see all field there, and you can copy it from this picture. Just save it to your computer. That is two ways, but if you want to create a really good field, I think you should to use maybe some programs for working with graphics, with vector graphics, maybe like